Hello, everyone. Thank you for joining, and I appreciate everyone's time that you spent on the weekend. I will make sure that you will learn definitely something from me today and our team. So let's get started without taking much time. Let me share my screen. Let me know if you guys can see my screen. Please say yes in the chat if you can see my screen and am I audible clearly.
Uh, okay, yeah, perfect. It's working.
Okay, great. So first of all, let me introduce myself. My name is Jamin Pathak, and I'm a security lead at Hack Security. I'm currently holding CEH version 11, which is currently active certification. Okay, so this is a small introduction about myself. I have around 13 to 14 years of experience in this cybersecurity domain. Okay, our today's webinar is let's talk about the agenda, how we are going to move forward. So first, I'm going to talk about the introduction about the Wireshark. What is Wireshark? Why Wireshark? Where to use Wireshark? Okay, so that is a small introduction that I'm going to cover about the Wireshark. Third, we will be seeing the how the Wireshark work, the main dashboard, how the interface look like, how from where you can download it. Okay, so that will be some of the things that we're going to go with the second part, walk through the Wireshark. Third will be analyzing the network traffic. So in which we are going to analyze the traffic of network, the network investigation part. And the fourth one will be security investigation, where we will be analyze some security incident in perspective, any kind of job or any issues comes with it. So this third and fourth part will be a very interesting because it will help you your day to day job. It will help you to your minimize your resolutions timing in the whenever you analyze any kind of traffic security investigation. That Wireshark will help you out in that. Okay, so let's talk about introduction to Wireshark. What is Wireshark? So basically, it's a protocol analyzer which captures and inspect the data across a network. It means the traffic which is going real time or even already traffic has been captured. We can analyze them in the Wireshark. Why? Because whatever traffic that is going back and from any network, it will be in the binary form. It is not actually in the human readable format. So Wireshark is helping us to decode that packet into the human readable format so everybody can understand it. Okay. So what are the common use cases for that? First one is the network troubleshooting. Second is the security monitoring and forensics. Third one will be the learning and analyzing the network behavior. So that's what we are going to do today, learning the network behavior. Okay. So what are the key features of the Wireshark? Live packet capture. We can take the live packet capture of the traffic and then if any packet already has gone through or if we take it from any devices like firewall, router, switches, then even we can take this and take it and analyze them. Second is filtering and search. In a particular second, you will find a lot of data going back and forth from the network. And in order to analyze them, in order to search for a particular traffic based on source IP address, port number, TCP port, TCP flags. So based on that, you will be able to find out the particular traffic with the help of certain filter that you may apply. Okay, deep packet inspection. Now, once you filter out that packet, it's not only just to search them, but we need to analyze them. Okay, so deep packet inspection is the lovable feature that you can see everything: source MAC, IP address, the destination, the port numbers, the URIs, TCP flags. So this will allow you to inspect that packet in a deep level, saving and exporting. It's not only just you analyze them. It's not only just you take some notes from them. You can even save them and even export them. So if you want to represent to someone in the management, it is also possible. Okay. Now, what are the practical application? Network troubleshooting, obviously. This third or second is security investigation. We can do any kind of malware analysis or any kind of threats, even that is possible. Protocol analysis and learning. Wireshark is actually supporting thousands of protocols and almost all protocols it is supporting. So even for a learning purpose, like I want to learn about how the traffic behavior of TCP, HTTPS, DNS, DSCP. So that also even you can understand via the Wireshark. Okay, let's go with the walk through the Wireshark. So this was just I covered the theory part. Let's go on the. Okay, I'm back. Yeah. So you have to visit the Wireshark official website, which is wireshark.org. Now go to the download section where you will find all the installer file for your relevant machine. It's for Windows machine, MacBook. Okay. So once you have that executable file, just run it, and you will have that installer file. Install it, and your Wireshark is ready. So I already downloaded it and installed it. So let me open that. So this is nothing but the Wireshark interface. Okay, it's the same application is there. Just need to open it after the installation. Okay. Now, once you open that, you need to capture a traffic on an interface. Okay, you will have all the options you can see over here. This is particular for the Windows machine I'm showing. Okay, so the interface which carries the traffic, you can see the live traffic like in the on an analog frequency. So you can see that the current traffic is going on the Wi-Fi adapter. If you have connected with the LAN adapter, you can see the Ethernet as well. Okay, based on your connectivity towards the internet, you can do it. So I'm going to select it and then just hit double click it, and then it will start capture. So this is nothing but the how to capture the traffic for this Windows machine. So you can see the thousands of packet where just in a couple of seconds it's going back and forth from that particular traffic. Okay. So before I go on to much more in detail, let's go with the some picture filter and display filter. Let me introduce that. What is that? Okay. So we need to understand about the capture filter and display filter. What is that? So capture filter actually applies before we process the packet capture. Okay. I just hit the Wi-Fi particular interface and it start capturing. So filter is a sense that we need to apply something. We need to search for a particular data, and that we are going to apply it in the filter, right? And that if it is a predetermined that okay, I know I what I wanted to capture. So that is nothing called as a capture filter. Display filter is applied after the after packet capture start. Okay, so not much more difference. Again, it is a difference of how the commands or the filter types are there. Okay, for an example, if I want to search for a DNS traffic, okay, if I want to go with this DNS traffic, then for the capture filter, you have to give the filter type as UDP port 53. I guess everybody knows about the DNS traffic works on port number 53. And in the display filter, same is there just by letting the name as DNS. Okay, so traffic will be same, but applying where and when you are applying, that is important. This is you are applying before packet capture start, and this is you are applying after packet capture start. Usually in our day-to-day job, we are using display filter much more because after the packet capture start, we are applying that filter. Okay, but this is just to introduce about that how this works. Okay, so let me show you that with a within a few minutes how to do it. So first of all, go to capture and option. Okay, now I if I know that I need to analyze the traffic with the capture filter, so I'm going to apply this UDP port 53 and start. Okay, so it will start all the packet capture just based on the predefined filter as UDP port 53, which is DNS. Okay, so this is your capture filter. Now I'm going to stop this and again start it. Okay, one more thing. This is a small sharp fin symbol. It is to start the packet capture. The second is to stop the packet capture. And in order to restart it, the third option is there to restart it. Because these are the some things, icons that we should know about it. Okay. And now I have stopped it. Now I want to again restart. So go to again options. First, I need to clear this and start it. Okay. So now again it started. Now I'm going to just apply DNS over here. This is your display filter. This is your display filter. Same messages are there, but when you are applying, that is important. So that is the difference between capture filter and the display filter. Okay. I hope it is clear. If clear, please say yes in the chat. Okay. Please say clear in the chat. Yeah. Okay. Okay. Thank you. Thank you. Okay. Now let's understand the more about the interface. So this is your main interface where you are working. These are your this is called pan 1, pan 2, pan 3. The first pan is showing you all the traffic means on which particular time it has been gone, means it when it captured. The second pan is to analyze detail about that packet. Okay, if you select a particular traffic and the detailed information about the traffic you will be able to see in the second pane. I hope you are aware about OSI layer. Means it is a frame that how the packets are going from one machine to the another machine. Those seven layers. So you can even correlate the same thing over here. Like the first one is your physical layer where you can find all the frame. Okay, how much amount of byte has been traversed. The second is your data link layer where the data is being switched based on the MAC address. So you will find the MAC address, the source MAC address, destination MAC address. The third is your network layer where you will find all the data and their data being forwarded based on the routing. So you will find all the IP addresses, source IP address, destination IP address. And then you will have a fourth layer, which is transport layer, where you will find all the TCP or UDP services and at their related port number, source port and destination port. So which information you want, then you can just click this arrow and detailed information about that you will be getting. And other layer like encryption, then application and presentation, you will find it over here under data. So data is obviously it is in the encrypted form, so this won't be able to see what kind of data is being traversed, right? And this one, the packet is visible under the like a hexadecimal form. So this is the packet information. It's in the hexadecimal form. Okay. More things about that you need to think in the pan one is like first column is time where the packet get captured. Second is your source from where the packet is being originated. Third is your destination where the packet is going and the relevant port number and protocol. Okay, the information you will even find it out over here. Okay, maybe whenever you start the Wireshark first time, you will see the time over here little bit different. So you can change it because time is very important. The time of event that has been captured, it is very important. So you can change it from here under the edit option. And you can go to the set or unset time reference. So you will be able to change your time according to your requirement or according to your comfort. Okay, so this is nothing but the pan information. If you want to even change the layout, there also this is also an option is there to change the layout as well. Okay, so I hope this is clear. This is the interface that it looks like very easy and it is very user friendly in order to understand the every packet. Okay, so let's go on to the next part, which is your network investigation. Okay, let's go with the network investigation. Okay, this is guys very important because still till now we have covered whatever it is was the information how to use it and the theoretical purpose. But when it comes to the practical, when it's somebody is saying that uh, give you a task on the job that I have some reachability issue, I have some packet loss, how to do that. Okay, so in the network investigation part for you guys, I have taken some 3 or 4 tasks and we have some objective and we will analyze the packet with the Wireshark and how to give a resolution on that. Okay, so I have around 3 to 4 tasks that we are going to cover in that. So first task is to find out the top talkers, the host with most traffic. So the objective is to identify which hosts are generating the most traffic. Well, sometimes what happen in the network, the users are experiencing some slowness, the applications are getting lagging. So at that time, it is very difficult to find out the root cause. And the root cause may be the high bandwidth utilization by some of the hosts, but it is very difficult to find out, right? You have the logs from in the firewalls, you have the logs in the router, but they won't tell you that this is the most top talkers, which is consuming more bandwidth and it is causing some CPU spikes and taking too much resources. So in order to find out those, we can use this Wireshark in order to find those, right? So first, I'm going to take some traffic and how to find out those top talkers. And even I'm going to provide the solution as well, how to resolve that issue. Okay, let's go to the Wireshark. Okay, I'm going to start the packet capture again. Okay, and I'm going to stop it. So till this time, it took a lot of packets it captured from my internet. And now go to the statistics and then conversation. Okay, this conversation it means the traffic which is going from a particular source and destination, all it got captured. Who sent and from how much traffic came from that particular destination, all will be captured. IPv4, IPv6, what are the TCP packet and UDP related traffic, all it has been captured. Now I'm going with the IPv4. Okay, you can see the columns are like address A and B. and then the packet bytes from A to B, B to A, everything is being written, right? Now, if I go with the just ascending or descending order like this way, see, you can see this. Let me just maximize this. The first one, I make it as in the descending order. So this is the address A first and address B. It took around 2 MB. Other traffic you can see it is just in the bytes, but the first one it took 2 MB. Okay, so when you capture a traffic in the devices like router, firewalls, so you will be able to take that file in the form of pcap. Okay, uh, sometimes it is not possible to take a live capture via attaching this Wireshark on that, so we have to take those from the devices and upload it over here. There's an option, and then analyze them, go to the conversation and find out the top talkers. So over here you can see this 192.168.29.35, which is my machine IP address, and 173 is some public IP address with which it is talking too much. So it's a 2 MB, right? So this is how you can find out that who is taking the too much traffic. Sometimes new applications are like the file transfer. So it's going back and forth between two hosts, and maybe it took a lot of amount of data from that, and other applications get lags, right? So with this, at least you will find out the who is the taking too much bandwidth of that traffic, right? Now, what is the solution? Now you find out the cause. Now, what is the solution? Okay. Now, first of all, once you know this is the legitimate users, or this are the not to be these are not to be dropped by firewall, then you can escalate that rules. Means you can escalate those traffic on the firewall. Now, what is escalation? Like it does not go into much more in the deep inspection kind of thing. It will smoothly go from the firewall without taking much time. Other than that, we can even recommend them to use those application if not required. Then, like file transfer, you can take them in the off hours. Now, if it is not the legitimate traffic, means the users are not identified that it is actually not the authenticated, then we can drop them on the firewall. We can create a rule and we can drop them as well. So this is the way you can go with the resolution part, that how to resolve this top talker issues. Okay, so this complete our first task. If it is clear, please say clear in the chat. The first task, great. I'm getting good response. Thank you, guys. Thank you. If any question is there, sometimes if I miss any messages, then I will answer. I will answer later on, or in between. Maybe Rajneesh can answer. Okay. Thank you. So let's move on to the next part, which is the second task. Okay, this one completed. The second is identifying TCP retransmission. Okay, what is the objective? Objective is to detect TCP retransmission and connection issue. Now, everybody is aware about, I guess, the how the TCP works. TCP works on the three-way handshake. Before the data is being transferred, it is exchange between client and server. The first three packets being exchanged, that is seen, SYNAC, and acknowledgement. Okay, the scene packet is the one of the six flags in the TCP, which is to initiate a connection with from the client to the server. Okay. Now, what happens if the server is unreachable, or it is unavailable? Sometimes what happens that even we don't know that server is down, it's a hardware down, or any kind of issues because of that in the network. I'm not able to reach it. So what will happen at that time? So client will make try to make a connection with the server all the time. So it keeps sending the scene packet to the server, right? It keeps sending the scene packet to the server, but as it is not available, you won't get what the acknowledgement from the server. Am I right? The second packet, if the server is available to respond, it will send the acknowledgement from the server to client. But if it is not available, then client will keep trying to reach. That is, the server is available. Let me try. Let me try. Okay. So in that kind of scenario, what will happen? You will see the TCP retransmission in the Wireshark. Okay. So let me show you the practically. Okay, I'm going to take any random IP address and I'm going to do HTTPS. Okay, I'm going to do the HTTP, generate the HTTPS traffic on that, and we will analyze it in the Wireshark. How the TCP retransmission look like. So first, I'm going to take any random IP address like HTTPS. Even I don't know what it is. Okay, now I'm going to apply this IP address in the display filter. The filter name is like ip.addr is equal to 45.8.6.9. Okay, let's start it and let's start capturing the target. Okay, I have again reloaded it. Now it start capturing in the background. You can see that. Even I don't know the what is this IP address. I have just taken the random IP address, which is not. So from my machine IP address is 192.168.29.35, which is the source. I am the source. And who is the destination? This one. And what I'm trying to do is I'm trying to send a packet to it, means I'm trying to reach it on which port? 443. HTTPS works on port number TCP 443, right? So you can see this 443, and it is coming from this random source port number, which is my machine port number. Okay. So you can see that it is first trying to make a connection. So it is sending the scene packet. So first, second, third, not I'm not getting the acknowledgement. If I would have, then I would see the second entry in which I can see the scene acknowledgement. But I can see this retransmission. I'm keep trying, right? So suppose the server is very far and you want to know if the server team is not available, what is going on. Then you can take a packet capture and you can see that if it is TCP retransmission is showing in the Wireshark or not. Okay, no router logs or something firewall logs will not show that it is it will only show that packet has been allowed and it is passing, but it will not show that is this the issue on the destination side or on the my side. So this can even at least confirm that that server is unavailable or unreachable from my side, right? So this is the second case where you can easily find out the TCP retransmission where if reachability issues is there. Okay. So this is the completes our task number two. Let's move on to the third task, who is taking the much more bandwidth by protocol. Okay. Like as I just we mentioned that it is like FTP protocol or TCP, UDP, ICMP. What kind of protocol which is taking too much bandwidth? We just now in the task one we have seen that it is top talkers we found out, but if I wanted to find out what protocol, what kind of services is being more utilized, okay, so it is also same. Go to the let me first of all stop it and then clear this, go to statistics, okay, and then again we can go to the conversation and we will find it out what kind of packets even in the TCP and UDP. Okay, so this will even show you the how much TCP or UDP, who is taking too much traffic. Okay, we can even do the ascending or descending order. So you can see this first, in which I can say it is this particular address A and B. It is taking TCP traffic around 1 MB, and this is a UDP in which 26 MB. So at least I came to know that this is the one who is taking UDP traffic. In the TCP, it's only a 1 MB, but UDP is some traffic which is only for this IP address. It is around 26 MB. If I compare with other IP address and the length of sorry, the packets or byte, it is too much higher, almost consuming much more traffic than other one. So even not only the top talkers, but what kind of protocol, TCP, UDP, ICMP, whatever it is, I can able to find out the even is taking too much bandwidth. Okay. So this is completes our task number three. The fourth one, analyzing ICMP traffic. Okay. ICMP is nothing but the ping. Ping we are usually used to first to check the availability of the remote end, right? We need to see the request and responses. How ICMP protocol works? ICMP protocol works like from A to B. If I wanted to go from A to B, if I want to check the B is available, then first packet I'm going to send as echo request. Okay, A will send a request packet to B. If B is available, and once it receive that request packet, what it will send? Reply. So it's your echo request, echo reply. Okay, first A will send a echo request, and second the I will get the reply, echo reply. Okay, so this is nothing but your ICMP traffic. ICMP is a different protocol. It's not a TCP or UDP. It's a different protocol. Okay, ping. I think everybody knows about ping. So this is nothing but the ICMP. Now, how to analyze? Now let's understand how to analyze. Okay, so I'm going to ping any domain. Let's ping any domain like ping Microsoft.com, and I'm going to use only IPv4. So this one. Okay. So this is the IP address. The Microsoft is 2076.201.171. And the statistics, this four lines is showing one packet. I mean, one line is showing one packet. So total four packet I sent and I received four. It means I'm able to reach Microsoft.com. Okay, there is no loss of communication, and around this much amount of time it took to reach there. Now, how to see this in the Wireshark? So first of all, let's go to the Wireshark. I'm going to take this IP address, or we can even run for, yeah, this will run continuously running. Now let's go to the Wireshark and close this. Apply the filter ip.addr is equal to and this and start it. Okay. So this is capturing now. Now the way ICMP works, just now I explained, the first packet will be going to as a echo request. So this is my source and destination is the Microsoft. This is the IP address which we just copied it. So first packet is going from my machine to the Microsoft. The protocol is ICMP. The first is echo request. The domain is reachable. The IP address is reachable from my side. So it is giving me reply. The second, just uh, just after that particular line, the second is in that you can see this source and destination got flipped. In the source now it is the Microsoft and the destination is my machine. It means Microsoft is replying me with the echo reply. So the number of packet that I sent, all are captured. Request, reply, request, reply, request, reply. So this way you can analyze the ICMP as well. Now where to use it? Sometimes why to use it or where to use it. So there is a whenever we call it reachability issues where I want to see if the destination is available or not. Like if I in this case, if I tell I want to see if the Microsoft is reachable or not. See, even if it is not reachable, you will get the RTO. That is request timeout within a 2 second. But this is the way you can even analyze in the Wireshark if it is really what kind of issue is there and what reply are we getting or not. So this is the analysis of the ICMP packet, how you can analyze this traffic. Okay. Is this clear to everyone? If clear, this completes our four tasks of network investigation. These are the most commonly used whenever any CPU hikes or top talkers issues or reachability issues, you can use them to analyze them. If yes, if you are clear, please say clear in the chat. So after that, we are going to go on the security investigation. Okay, okay, I'm getting good response. Thank you. Uh, let's take a 2-3 minutes break, and then we will go on to the security investigation. Thank you for answering the queries. Uh, okay, guys, so let's continue with our security investigation part, which is the last part of it. Is very interesting as well. So yeah, uh, the lab topology that I have created for this, it's a Kali and the Metasploitable too. Where I guess many of you have heard about this Kali and Metasploitable too. Let me just what their purpose is. Kali is the machine where it is majorly used by the ethical hackers or even the unethical hackers in order to perform some attacks. And Metasploitable too is the victim machine. The people are the those hackers are using. So it is actually vulnerable machine, which is having a lot of vulnerabilities in that. So it is even for learning purpose, it is very useful. Now in this cloud topology, I'm going to perform some nmap command from the Kali. So Kali is the source from where I'm generating the traffic to the Metasploitable tool, which is the victim. Okay. And I'm going to run the Wireshark on the Kali. So we can analyze this packets on the Kali itself. So where you are putting the this Wireshark, it is main important because if you are putting on the Kali, so the source is Kali and the destination you have to refer as a Metasploitable. So let's go with the first task. Still scan. What is still scan? Still scan is nothing but the half TCP connection. Uh, we heard about the full TCP scan, like what is the TCP handshake. But still scan is nothing but the half TCP connection. It is majorly used in for a good reason. Like if I want to scan a thousands of port, then it is used that then I can use it as tail scan. How it is going to work, I'm going to explain in the next slide. But we are going to simulate this tail scan, and objective is will be how to analyze them in the Wireshark. Okay, this is to first discover the open port. Okay, now let me make you explain what is this tail scan. This is all we know. The client and one second. Yeah. This is our normal three-way handshake, TCP three-way handshake, right? But in the steel scan, what happen is if the port is open, okay, if the port is open, then in the second acknowledgement, when the server respond, that suppose I am trying to see if 443 is open on this server. Okay, so first I send the scene packet, and the if it is open, then server will respond with the CNAC. But in a normal case, what happened? The acknowledgement will be sent. But in this tail scan, this will not happen because in the second packet itself, I confirm that okay, 443 is open. I don't want to establish a connection. I don't want to make a connection. I just want to know if this port is open. That's my task. I don't want to make any connection. So instead of sending acknowledgement, it will send what? Reset. Okay. It will send what? Reset. So the connection will be closed. But if the port is closed, suppose 443 is closed, then server will respond what? The reset. Okay. Server will respond with the reset that this port is not open. So with this, I'm not establishing the connection and my purpose is fulfilled. Like I will know that particular port is open or not. Now let's run this command. I'm going to use nmap, and then the command is nmap -ss and the target IP address. Okay. Over here, my target IP address is 10.038. I will verify one more time. And the Kali is dot 7, 3.7. Both are in the same network, so I can easily perform the attacks and the scanning. So, but even let me verify. This is the Metasploitable 2. Um, I have deployed both these VMs in the Oracle VirtualBox. Okay. So let me first check the IP address. Sorry. So it is 10.038, and I'm going to run the command from Kali. This is my Kali Linux machine. From the terminal, I can perform it. But as we need to analyze this traffic on the Kali side, so let me open the inbuilt application which is come with the Kali. This is your Wireshark. Okay. I have to select what port I need to capture on it. So Ethernet 0. It is being started. Let me zoom in so everybody can read it. This is the terminal from I'm going to perform the attack. Okay. Now let's run the command nmap small s, capital S, and the target IP address, which is 10.0.3.8. This is your Metasploitable 2. Okay. See this. First, let's understand the output. Okay. Already we got the output. See, I run this command and I got the output. So it is scanning this host, and host is up. These are the ports that are open, and there are other 977 ports are there which are closed. Okay. Because it's not showing because it will be a long list will be there. So it is only showing the ports which are open. On where? On the Metasploitable 2. So now, if the port is open, let me pick up the 6000 number port. 6000 port. So if the port is open, as per our theory, what it show? It will show the reset, right? So let me go to the Wireshark. Okay. I'm going to filter out with TCP dot port. This is another way you can apply filter based on the port number. And the port number was 6000. See, first from my source, which is Kali, to the destination Metasploitable, I can see it is going the scene packet on the port number 6000. This 46300 is a random source port generated by the Kali. In the second line, I can see the response is coming from the Metasploit table to the Kali that yes, the port is open. I am sending scene acknowledgement. The third one is your reset. Instead of acknowledgement, you can see the reset. Why? Because my purpose is fulfilled. I know that port is open. I don't want to make any connection with you. So I'm closing this connection and I'm sending the reset. Okay. So with this, you can identify that how many number of ports are there without even running a full TCP scan. It will save your time. Okay. It will save your time. Now the next task is to see if the what kind of what it will be look like if the full TCP scan will be running. So I'm going to show you the second task as well. This is in order to run that command. So it will be your nmap -st. Okay, command is same command is there, but instead of s, it will be your t. T stand for full TCP scan. So let me run that, and we will again see the same port 6000 how it look like. Okay. Now let me go to again this nmap -st n03.8. Okay. Let me go to the Wireshark. First, I'm going to stop. Sorry. And again start it. Okay. This is one which is coming from the previous one. Okay. So you can see this scene, SYNAC, and acknowledgement. Okay. Now I'm running full TCP scan. So based on the theory, full TCP scan means I'm trying to make a connection as well. So scene, SYNAC, and acknowledgement. All three packets you can able to see this. But this takes a time. Those are know about little bit about the ethical hacking or something. So once they are trying to do any do the scanning, so they run half TCP scan because they don't want to create a connection, and it will even uh, very fast. The with the if I compare with the full TCP scan, it is very much fast than the its one. Okay, so this is completes our task number two, full TCP scan. Previously, it was the half TCP scan. I hope it is clearly understandable what is the difference between them. Okay, let's move on to the task number three, OS fingerprinting attack. Okay, if I wanted to know that what is the destination's operating system look like, okay, I want to know this is a part of reconnaissance. This is the very first part. If I want to identify what kind of target it is, what version, what operating system it is there, before performing any attack or before knowing the network, we must know what are the devices are there, what vendors are there, and what versions they are running. After that, you can exploit any kind of vulnerability if it is exist. So OS printing is the very first task in order to identify who is my destination. Okay. So our objective is to identify operating system running on a host. Now let's find out who is the metasploitable, means what kind of operating system it is. So I'm going to just run ping command, okay? And I will, from the ping itself, I will be able to find what is the operating system of metasploitable 2. Okay. So let's go to the again Rally machine. And first I'm going to stop that. Okay. And remove this. Okay. And then start again. Now let's ping. Okay. I'm able to ping it because they are in the same network. Now let's go to the this one. Okay. The packet has been captured. Now let's select one. Okay. Let's select one and go to the IPv4. Now under this, you will be able to see this time to live. Time to live, it is nothing but your TTL value. TTL value is referred as 64. So 64 value, what operating system it represent? Linux or Mac OS? MacBook and or the Linux machine has the TTL value as 64. So at least I know that this is the target machine. The Metasploitable is the having Linux operating system base, right? Now I can find out the version, and then if any kind of vulnerability is associated with that version, then I can make an exploit and trying to hack it, right? So, but first, this is the very first task in order to identify what is the target. So 64 value, 64 from the TTL value I identified. If the value is 128, then it will be your Windows machine, right? I hope it is clear how to identify the target OS machine. Okay. Now let's move on to the fourth task, which is your detecting. Sorry, the fourth task is to run idle scan attack, IP spoofing. Okay, what is spoofing? Spoofing is like to spoof the original IP address. Okay, to pretend that I am a part of internal network. Okay, what hackers do is they change their IP address into the internal IP address, so it look like this is a legitimate traffic which is initiated from the inside network. Okay, this is called spoofing. So why spoofing they are doing? They are doing this because for the DDoS attack. DDoS attack, it's a distributed denial of service attack. Okay, let's understand first DOS means DOS, denial of services, something to deny. Okay, in this attack, what the hacker is doing, it is overwhelming a target server with the fake connections. Okay, it overwhelming a target with a fake connection. So the target machine or server cannot serve the legitimate users. Okay, they cannot serve the legitimate users. So what happened after that? It means I am denying the services to the legitimate users. And why it's called distributed denial services? Because the hacker perform this attack from multiple sources. Maybe they are geographically located in different location, and they send a lot of spoof connections to the target. Now, what happens over here? In this one, they change their IP address to the target, and then target target what will happen? The target when the target replies back, okay, it will reply onto the spoof IP address, right or wrong? But it does not exist because it has changed. The original IP address target does not know. So where to go? I don't know, right? So target will be overwhelmed with this spoof scene packet. It is even referred as a scene flood attack, okay, because lot of scene packet you will find it out. Okay, so I think this the I think you understand what is DDoS attack now. The command is to perform this attack is nmap S, then a capital I, zombie IP address. This is even referred as a zombie attack as well, in which I'm going to use any different IP address, not the actual Kali IP address. And any IP address we can do it. And target IP address is our metasploitable. So let's move on to the this attack. Okay. So first of all, let me stop this. Stop and start. Okay, this will start from beginning. And now I'm going to run nmap -s capital I, the zombie IP address. Anything you can take 4960 666, and then target IP address is our metasploitable 2. Okay. See in the background it start capturing. Okay. Okay, I'm stopping this. So now we can see this 149.6.6. Okay, and TCP retransmission. Why? Because it keeps sending scene packet. I want to make a connection, I want to make sure. So you can see a lot of TCP retransmission. It means it's a flooding of scene flood attack. the it will it will consume most of that resources of the target server, so it cannot serve the legitimate services, right? So this is called distributed denial of services. With this, you will be able to find out if the DDoS is happening in the network or not. In the organizations, they do have DDoS protections. The checkpoint firewall, checkpoint company has their own DDoS protector as well as a dedicated hardware is there. So different vendors has a different kind of solutions, so they can apply it. Okay, but this is how you can identify even attacks or malware as well. Okay, so because we have just a 1 hour or 1.5 hour, I cannot cover a lot of malwares, but we can do it with the Wireshark as well. So this complete our security investigation. These are the fourth task that I want to cover. I hope this is clear to everyone.